Alright guys, here's your homework for today. We're on page 681 and 682. So we're page 681, 682, and we are right here. So we're adding mixed numbers, same thing we did for the lesson, and they always give me a sample problem that I'm going to be doing on my homework. So here's my sample problem, 4 3/8 plus 7 1/4. Hopefully you see, right, I can't add 8 plus 4 in fractions. Nope. I have to change my denominator so they are the same number at the bottom. So I'm going to change them to an 8. I'm going to change my 7 1/4 to a 7 2/8. I multiply the 4 times 2 and I multiply the 2 times 2. So now I don't do anything with the 7. The 7 stays exactly like it is. I'm only multiplying the numbers, the digits on the fraction. So now I can add 4 3/8 plus 7 1/4. Instead, I'm going to add 4 3/8 plus 7 2/8. So now I add my 4 plus my 7. I get 11, right? They just moved this number over here. I broke my number up. So hopefully you guys remember, I can always do that. Right here, this would be equal to 4,000 plus, well, there's nothing in the hundreds place, 30 plus 2, right? That's all I'm doing here with my fraction. I'm writing it in two pieces. 4, the 7, I broke it up. So now I have 4 plus 7 is 11, 8, 8, 8, and I add my numerator. 3 plus 2 is 5. This cannot get any smaller, so my final answer, 4 3/8 plus 7 1/4 equals 11 5/8. All right, practice. Now I'm going to add 2 1/10 plus 5 7/10. Oh, so I just add my whole numbers. My 2 plus my 5 is 7. I'll make my fraction, right? There's my fraction line. I know my denominator is going to be 10, 10, 10, 10. My numerator, I add the numerators for both of the numbers. 1 plus 7 is 8. I have 7 8/10. And hopefully you notice, 8/10. Wait, I can divide both of those numbers by 2. So I'm going to do that. I'm going to divide my top by 2 and my bottom by 2. I leave my 7 alone. I do not divide anything with it. There's my fraction line. So 10 divided by 2 is 5. 8 divided by 2 is 4. So I have 7 4/5. All right, my next problem. I have 9 plus 8, right? 3/4 and 3/4. I'm going to add that together. But my 9 plus my 8. So my 9 plus my 8 is going to give me 17. And then 4, 4, 4. 3 plus 3 is 6. And hopefully you see, wait, this is an improper fraction. The numerator is bigger than the denominator. The number on the top needs to be smaller, right? That's the whole point of fractions. We're counting a piece of a number. So I'm going to find out what this is equal to. I'm going to take 6/4. I can divide my 6 by my 4. Or I can just do a reverse math problem. I'm going to add, right? I know I'll have two numbers. They both will have a 4 in the denominator. This one, I want it to be equal to 1. And I know 4/4 is equal to 1. And 6/4, right? So I'm going to have 4 plus 2 is equal to 6. 4, 4, 4. 4 plus 2 is 6. So now I'm going to have 1 2/4. Hopefully you can see that 2/4 is equal to something else also. So I'll bring my 1 over. 4 over 4 is 1. 2/4 I'm going to divide by 2. Divide by 2. And then I will have 2 divided by 2 is 1. 4 divided by 2 is 2. So I'm going to have 1 1/2. So I'm going to add my 1 to my 17. Right? My 6/4 is my 1 1/2. My 6/4, I change it to 1 1/2. So this would be like writing 17 6/4 is equal to 17 plus 1 1/2. 17 plus 1 is 18 and my half. So this is going to be equal to 18 1/2. Final answer. All right, next problem. 3 5/8 plus 6 1/2. I can't add this 8 to that half there, right? 5/8 and the half, no. So I'm going to change this to an 1/8. So I'm going to times 2 on the bottom, times 2, times 4 on the bottom, times 4 on the top. So 4 times 1 is 4. 4 times 2 is 8. I'm going to have 4 eighths. Now I can add. 3 plus 6 is 9. My denominator is 8. 8, 8, 8. And now I'm going to add my numerator. 5 plus 4 is 9 eighths. But hopefully you're like, whoa, 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 we can't leave that 9 eighths. That's a improper fraction. So I'm going to take 9 eighths, and I'm going to do a reverse addition problem. I'm going to add two numbers together. 8, 8, 8. Right, this is going to have to be an 8 to turn it into my 1. And 8 plus 1 is 9. So now this is going to be equal to 1 and 1 eighth. So I'm going to take my 9 and 9 eighths and add. I'm going to take my 9 and 9 eighths. And I changed it, right? Now it's going to be 9 plus 1 and 1 eighth, which is equal to 9 plus 1 is 10 and 1 eighth. Next problem. Oh, it's a nice one. The 12, 12, 12. So I'm going to add 4 plus 1 is 5. My fraction is going to have a 12 on the bottom in the denominator. 12, 12, 12. 5 plus 1. 1 plus 5 is 6. Oop, both of these numbers are divisible by 6. Their least common multiple is 6. So I'm going to divide the top by 6, divide the bottom by 6 to simplify my answer. So now I'm going to have 5. 6 divided by 6 is 1. 12 divided by 6 is 2. 5 and 1 half. Alright, next problem. I have 15 and a 5. Nope, not going to work. I need to turn this 5 into a 15. So I'm going to take 3 times 5. Whatever I do to the bottom, I have to do to the top. So now I have 3 times 3 is 9. 3 times 5 is 15. Now I can add. So I'm going to have 11 plus 6 is 17. There I'm going to draw my line for my fraction. I know my denominator is going to be 15, right? 15, 15, 15. My numerator is going to be 9 plus 4. So 9 plus 4 is 13. I cannot simplify that or make it any smaller. It's just 17 and 13 fifteenths. Alright, last one over here on this page. 9 and 1/2 plus 12 and 11 twentieths. Right? I can't add a 2 and a 20 in my fraction, right? But I can turn a 2 into a 20 pretty easy, right? I just multiply it times 10. So whatever I do to the bottom, I have to do to the top. My new fraction is now, instead of 1/2, it's going to be 10 over 20. Right, I could have just added a 0 on the end there to make it look a little neater. So now I can add 9 plus 12 is 21. My fraction is going to have a 20 in the denominator, right? 20, 20, 20. My numerator is 10 plus 11, which is 21. So this is 21 and 21 over 20. No. Improper fraction. We're going to fix that. So I'm going to say 21 over 20 is equal to a math problem. I would add two fractions together, both with a denominator of 20. This one I'm going to put 20 over here so I get my 1. And 20 plus 1 is 21. So now 20 plus 1 is 21. 20, 20, 20. Right, I just wrote my math problem a little backwards. So this is going to be equal to the 1 and 1/20th. So now I need to add this, right? I had 21 and 21/20ths, but I changed it. So now I have 21 plus 1 and 1/20th, which equals 22 and 1/20th, right? This is a unit fraction, and with a 20 on the bottom, it's very small. All right, pause it if you need to, if I went too fast. Sorry, my phone's over here. All right, a flower is 9 3/4 inches tall. In 1 week, it grew 1 1/8 inches. how tall is the flower at the end of the week? Right, in simplest form. So my flower used to be this tall, 9 3/4 inches, and it grew a little bit, so it added a little height onto it, 1 1/8 of an inch it grew. So now I'm going to just add these together. So my 4 over here, I'm going to turn it into an 8. So to turn my 4 into an 8, I'm going to multiply it times 2. And whatever I do to the bottom, I do to the top. Whew. My phone didn't crack. Yay. All right. So 2 times 3 is 6. And 2 times 4 is 8. So now I have 9 6/8. Sorry, it's hard to see, huh? Plus 1 1/8. So I'm going to have 9 plus 1 is 10. My numerator is going to be 8, right? 8, 8, 8. I'm going to add my denominator is going to be 8. I think I said numerator. My denominator is going to be 8, 8, 8, 8. My numerator, I'm going to add these two numbers together. So 6 plus 1 is 7. I have 10 7/8 what? Flowers, weeks, inches. Right? How tall was this flower? It is 10 7/8 inches. If someone asked me to round this, I would say it's almost 11 inches. Right? I like to use whole numbers rather than fractions, but sometimes I need to be very specific in my math. So, all right, here we go. Find 10 3/7 plus 18 2/7, write in words in simplest form. All right, so let's write it in numbers. They gave it to me in words. Let's write it in numbers, add it together, and put it back into words. All right, so 10 3/7, right, is going to be 10 3/7 plus 18 2/7. 18 2/7. Well, at least they gave me like numbers right there in this problem with their words. All right, so 10 plus 18. Right, I add my 8 to my 0, and I get 8, and I add my 1 plus my 1, I get 2. Now I'm going to add my fraction together. I see 7, 7. My denominator is going to be 7. 3 plus 2 is 5. 28 5/7. But we're not leaving it right like that, right? This is simplest form, but I have to write it in words. So I'm going to write 28 and I'll put a little hyphen. My 28 and 5, and they put a hyphen there too. 7ths. 28 5/7. I wrote it in word form. All right, here's Connor. Connor is filling a 15-gallon wading pool, right? The baby pool is just a wading pool. If you wade in water, you can walk in water. If you're wading in it, it's like you're not walking on the water, you're walking in the water. That's called wading, and I call it a wading pool, the little baby pool. On his first trip, he carried 3 1/12 gallons of water. He carried 3 5/6 gallons on his second trip, and 3 1/2 gallons on his third trip. Suppose he carries 5 gallons on his next trip. Will the pool be filled? I'm looking for 15 gallons altogether. So let's see how much he's already put in his pool. So I'm going to try and get 15 gallons, right? My question what do I know? I know he has a 15-gallon pool. I'm going to guess he's trying to fill up all 15 gallons, right? Normally I wouldn't. I'd leave a little edge with some room so it doesn't splish splash all over when everyone gets in. But we're going to guess Connor, because it's just our math problem from our book. He's not going to do that. He's going to fill all 15 gallons. So that's what we're looking for. So he had to carry trips of buckets of water over to fill up the pool. He doesn't have a hose. So this is how much water he carried. We're going to add it up and see if it equals 15 and if his pool is filled, right? That's what do they want to know? They want to know, will the pool be filled? Explain. All right, so I'm going to do 3 1/12 is my first trip that he filled up with water, plus 3 5/6 is my second trip he filled up the pool with water. My next one, 3 1/2, the amount he put in the gallons in the pool. And his last trip, he put a whole 5 even gallons in there, plus 5. So we need to figure out how much this is and see if it equals 15. Well, first I'm going to change some numbers here, right? I see 12, 6, 2 are my denominators. I need to make these all the same number, right? So I would look for my greatest common multiple of these numbers, right? I stopped kind of doing that because my 12, I know 6, right? If I count by 6s, 6, 12. I can count by 2s, 2, 4, 6, 8, 10, 12. Right? This is the smallest number that all 3 of these have in common. 12 is a 12. 6 can turn into a 12 times 2. 2 times 6 is 12. So I'm going to say, I'm going to turn all these numbers into a 12. I don't have to do anything with that 5. It's just a 5. Leave it a 5. So to turn a 6 into a 12, I multiply it times 2, 12. If I do that to the bottom, I have to do it to the top. 2 times 5 is 10. So I have 10 12ths now to add that. I have 1/2 here. If you guys are getting, I wonder if you guys are getting this now. It always is a number when I do 1/2, right? If I need a 12, I don't even have to do that. I just know 12 here on the bottom, it's going to have a 6 on the top because 12 is half of 6 with my half fractions. But you could do it the other way we have been doing. Multiply the bottom times 6, multiply the top times 6. All right, now we're adding 3 plus 3 plus 3 plus 5, right? 3, 6, 7, 8, 9 plus 5, 10, 11. I put the 9 in my head. 10, 11, 12, 13, 14. So I'm going to write my 14. I switched to purple so that you can see a little better, hopefully. All right, so now I'm going to add my fractions. I'm going to stick with purple. I'm going to say my denominator is 12 because I have 12, 12, 12, 12. Now I'm going to add my numerators. 1 plus 10 is 11 plus 6. 11 plus 6 is 17. Right? I can already tell his pool is overfilled. Right? Because I know 17 twelfths, right? 1 plus 7 plus 6 is 17. 17 twelfths is an improper fraction. I need to fix that. So I'm going to change my 17 twelfths. I'm going to do my work over here. 17 twelfths. I'm going to turn it into a reverse math problem. I'm going to say 2 numbers add together. They are both twelfths. And when they add together, I have 17 twelfths. I want to make sure one of them is 1. So there's my 12 twelfths. 12 plus 5 is 17. So I'm going to have this is going to be equal to 1 and 5 twelfths. So now I'm going to add my 14 and 17 twelfths. I'll just write it right here since they gave me lots of lines today. 14 and 17 twelfths is equal to 14. 17 twelfths is 1 and 5 twelfths plus 1 and 5 twelfths, which is going to be equal to 15 and 5 twelfths. Back to my question. Will the pool be filled? Yes. Connor filled the pool and had 5 12 gallons left over. Right, it was a 15 gallons he needed to fill the pool. He got his 15 gallons plus another 5/12 of a gallon. All right, here is Benjamin. Benjamin had 2 1/3 gallons of fruit punch Benjamin had 2 1/3 gallons of fruit punch left after a party. He had 1 3/4 gallons of lemonade left. How many total gallons did he have left? So he had this much punch, this much lemonade. We're going to add it together to see how much juice, how much drinks he had left, how many gallons of liquid de bebidas sería. Alright, so 2 1/3 plus 1 3/4. We're adding, 4 and a 3. I can't do it, but I remember my super nifty trick. I'm just going to multiply my 3 times my 4 to find my common denominator of 12. Right? If I take 3 times 4, I know that's going to be equal to 12. It's kind of cheating, right? I'm not finding my least common multiple. Sometime this number will be bigger. There was a smaller number you could have used that's not the least common multiple, but it will work every time. All right, so 3 can turn into a 12 by multiplying it times 4. And whatever I do to the bottom, I have to do to the top. So now this is going to turn into 4 over 12. And over here, I'm going to multiply times 3, because I multiply my bottom times 3. I should have wrote it over here. So 3 times 3 is 9. 3 times 4 is 12. Now I can add. 2 plus 1 is 3. I turn my 12ths. 4 plus 9 is 13. So I have 3 and 13 twelfths. Whoop. I'm not going to leave that like that, right? 13 twelfths plus there's no answer over here. That is 3 and 13 twelfths. So I know I need to do more work. 13 twelfths. I'm going to do it that same way again. 13 twelfths is the same as two numbers added together, both fractions with 12 in the denominator, right? 12, 12, 12. I want to have one of them be one whole number, so 12. Right? If sometimes this really only works well with these kind of numbers. If you have bigger numbers, you might not want to do this way, but we'll do it for now. All right, 12 twelves. 12 plus 1 is 13. So I know this is going to be equal to 1 and 1 12th. So now I'm going to add. I'm going to replace my 13 twelfths. Now I'm going to have 3 plus 1 and 1 12th, which is equal to 3 plus 1 is 4, and I still have my 1 12th. 4 and 1 12th is an answer over here. It is letter A. Done. Sorry for taking so long. Again.